Welcome to our training on corrosive safety. You are taking this course because you work with corrosive materials. A corrosive substance is one that will damage or destroy other substances it contacts by means of a chemical reaction. The reaction can cause harm within seconds and have long-lasting health implications. This reaction can take place on skin, metals, cloth, and other surfaces. By the end of this course, you will be able to recognize types of corrosive materials and their hazards, identify and read corrosive material labels, recall chemical safety guidelines, know how to safely use corrosive materials, know the proper techniques to store corrosive materials, and decide actions to take in an exposure emergency. Corrosives can burn and destroy body tissues on contact. At very low concentrations, weak corrosives may only cause irritation. The stronger or more concentrated the corrosive material is, and the longer it touches the body, the worse the injuries will be. Most corrosives are either acids, substances with a pH less than 7, or bases, substances with a pH greater than 7. Common acidic corrosives include hydrochloric acid, hydrofluoric acid, sulfuric acid, chromic acid, acetic acid, and nitric acid. Common basic or alkaline corrosives include ammonium hydroxide, calcium hydroxide, potassium hydroxide, caustic potash, and sodium hydroxide, caustic soda. Liquids are often the main source of skin exposures to corrosives. Acids and bases damage tissue in different ways. While acids tend to produce immediate pain at the site of contact and begin to harden the skin, bases do not produce the same immediate warning. Burns from bases like potassium or sodium hydroxide can be much more severe due to a delay in pain, which allows the base to sit on the skin longer and penetrate deeper. When bases contact the skin, they begin reacting with triglycerides in skin oils and feel slippery or soapy, which can make them harder to remove than acids. While most skin exposure to corrosives is from liquids, dust from some solid corrosives can produce both internal and external injuries. The same is true for corrosives that produce vapors as well as corrosive gases. Inhalation is the greatest concern for internal injuries. Corrosives that damage lung tissue will cause chemically induced pulmonary edema. The eyes are particularly susceptible to dust and gases due to their moisture content and delicate nature. Eye contact with corrosives can cause permanent damage, including blindness. This makes protection of the optic nerve with correct personal protective equipment and prompt and proper eye washing particularly important. Corrosivity isn't always the only hazard. There are toxic corrosives like hydrofluoric acid and trifluoroacetic acid that can harm organ systems apart from the skin. Swallowing corrosives can burn the sensitive lining of the mouth, throat, and stomach. Inhaling corrosive gases, vapors, or particles will irritate and burn the inner lining of the nose, throat, and lungs. Pulmonary edema, a buildup of fluid in the lungs, can occur and can be fatal. It can take several hours for symptoms to fully develop, like pain or redness. By this time, significant soft tissue damage can occur as well as damage to bone tissue. Which type of corrosive usually produces an immediate pain when concentrated forms contact skin? Corrosives can damage containers, equipment, and building components. When acids react to metals, hydrogen gas is often given off. This is a flammable gas which can burn or explode if an ignition source is present. To prevent unexpected reactions, refer to safety data sheets before choosing which chemical containers and storage cabinets you use to store corrosives. Many industries use corrosive materials for cleaning industrial components, as well as for rust and corrosion removal on parts. Other industrial uses include wood pulping for paper manufacturing, etching glass products, water treatment, and electrolytic fluids for batteries. You will also find corrosive materials in laboratory operations, chemical production, and in cleaners for food preparation stations. We know corrosive materials are used in industrial settings, but did you know many common household items are also considered corrosive materials? Look at this picture and select the items considered corrosive. Because corrosive materials are present in most workplaces, either by themselves or contained in other products, it is vital that you know how to recognize the type of corrosive material you are working with. Knowing which corrosive materials are present will help you take the proper precautions to stay safe. Ways to identify the presence of corrosives include training, safety procedures, container and pipe labels, signs, pictograms, and chemical inventory lists. Labels tell us about chemical dangers and precautions to be followed. The manufacturer's label usually suffices, unless you need to transfer into another container. If material is transferred into another container, a new label should be prepared and attached to the new container. Maintaining the accuracy and legibility of these labels is essential. Select each section of the label to see what information is included. What information is commonly on corrosive material labels? Choose all that apply. Chemical safety guidelines and work procedures are written documents that outline the hazards present in a work environment and explain the processes, protocols, tools, and equipment that are available to help workers guard against those hazards. Like many safety plans, these documents are living documents that need to be reviewed and updated often by designated personnel. Although plans are often specific based on work environment, the chemicals used and the processes, there are specific elements that should be contained within the plan. Chemical hazards pose many risks to people in the workplace. To minimize the negative effects of these hazards, it is very important that you implement the most effective controls first. It's not just PPE. Select safer chemicals, processes, work practices, and procedures along with PPE, rather than using PPE as a substitute for these other procedures. It is important that equipment undergoes regular maintenance to prevent leaks or emissions of corrosives into the workplace. Maintenance personnel should be made aware of the hazards of the corrosive materials they will be required to use in their jobs or might be exposed to in the workplace. It is essential that they are aware of any special procedures and precautions that need to be taken before breaking into piping or beginning work on corrosive-containing equipment. When possible, corrosive chemicals should be handled in a fume hood to ensure that any possible hazardous or noxious fumes generated are adequately vented. Chemical fume hoods, when used properly, are one of the most reliable engineering controls in the laboratory. They protect workers by containing vapors, dusts, gases, aerosols, mists, and fumes generated within the hood, and removing them through filtering and exhaust ductwork. They also provide shielding with a clear sliding window called a sash that helps prevent injury from splashes and other incidents that may occur inside the hood. Good housekeeping, personal cleanliness, and equipment maintenance are important wherever any chemicals, including corrosives, are used. Take the following actions to maintain cleanliness and order. Keep floors, counters, and work areas clean and dry to help prevent unplanned and unwanted chemical interactions. Keeping workspaces uncluttered decreases the likelihood of reactions and spills. Ensure spills are cleaned up promptly. Likewise, limit chemicals around your workspace. Keep containers closed when not using the chemical agent. This will minimize the chance of accidental spills and reactions to incompatible material. Remove empty containers at once from work areas. Properly dispose of expired chemicals. Ensure that all containers for waste are properly marked and easily located. Wash hands after removing protective gloves and before eating, drinking, smoking, or using the restroom. Remove and clean contaminated clothing before wearing it again. Do not smoke, drink, chew gum, eat, or apply lip balm or other cosmetics in any areas where hazardous chemicals are present. Store food and tobacco products in uncontaminated areas. Personal protective equipment, PPE, is another measure you can take to help prevent or reduce the severity of harm from corrosives. To protect yourself from contact with corrosive material, follow personal safety guidelines. Wear and maintain personal protective equipment and apparel. Protective clothing must be made of materials that resist penetration or damage by the chemical. This may include gloves, eye and face protection, respiratory protection, protective footwear or coverings, and body protection such as a smock, apron, or coveralls. Designated personnel at your worksite will determine the correct PPE needed through a review of the chemical needed for the job, the SDS, and the task. The SDS should recommend appropriate materials. If it does not, contact the chemicals manufacturer or supplier for specific information. Avoid breathing corrosive vapors, fumes, dusts, or mists. If respirators must be used for breathing protection, there should be a written respiratory protection program to follow. True or false? If you wear gloves while working with corrosives, you do not need to wash your hands before eating. When using corrosive material, you should take precautions to reduce your exposure and protect yourself from harmful effects. Select each term to learn more. Transferring liquids from shipping and storage containers may cause exposure from splashing or overfilling. To minimize risk of exposure, use corrosion-resistant drum pumps or hand pumps. Do not pressurize the drums with air to force the transfer. Ordinary drums and barrels may be damaged by the pressure. Always wear required protective equipment when handling corrosive material. Many corrosives, both solid and liquid, create heat when they are mixed or diluted in water. This process can cause temperatures and pressures to rise, causing the solution to froth and boil, and possibly erupt violently from the container to the surrounding area. Due to this reaction process, add the corrosive material to water slowly and in small amounts, and stir the mixture frequently. Always use cold water in the mixing process. Do not mix strong acids and bases. Mixing strong acids and bases can result in intense, rapid reactions. Drums and containers can fail catastrophically, spraying corrosive contents in all directions. Select each item to learn how to reduce spills and exposure while carrying containers with liquid corrosive material. Routine inspections of chemical storage areas and maintenance of stringent inventory control can reduce the overall risk of chemicals. Minimize the quantity and hazards of chemicals on hand. All chemical storage areas and cabinets should be inspected periodically, and any unwanted or expired chemicals should be removed. Keep the amount of corrosive material in storage as small as possible. Practice first in, first out management of stored chemicals. When strong chemicals must be used, proper storage and handling can reduce associated risks. Proper storage information can usually be obtained from the safety data sheet, label, or other chemical reference material. Regularly inspect storage containers and areas for corrosion damage, leaking containers, incompatible materials, and poor housekeeping. Check the readiness of spill kits and eye wash stations. Report and correct all deficiencies as soon as possible. Typical storage considerations may include temperature, ignition control, ventilation, separation, and identification. Proper segregation by distance and barriers may be necessary to prevent incompatible materials from inadvertently coming into contact. One good practice is to identify cabinets and shelves where chemicals should be placed. Labeling the predetermined storage locations helps ensure incompatible materials are kept apart. Expect the possibility for corrosive residue on the outside of containers. Wear gloves to avoid incidental contact with corrosive chemicals. Review the SDS for incompatibility and reactivity concerns. For example, acids and bases react together, sometimes violently. Storage areas should be well ventilated, dry and in cool areas, out of direct sunlight, and away from heat sources like steam pipes or boilers. Follow the chemical manufacturer's or supplier's recommendations for storage temperature. Avoid rapid temperature changes in corrosive liquid storage areas. If a tightly sealed corrosive liquid container is cooled suddenly, a partial vacuum could form, and in extreme cases, the container might collapse and leak. If a sealed container of a corrosive liquid is stored in direct sunlight or near other heat sources, vapor levels in the container can build up. This leads to an increase in pressure in the container. In severe cases, this could cause the container to rupture. A buildup of pressure might also result in the material spraying into the face of the person opening the container. How can storing corrosive material in direct sunlight impact the chemical? Most workplace injuries caused by common corrosives such as acids and bases result from accidental skin or eye contact. Be ready to act fast to handle emergencies. Before using any corrosive chemical, know where the closest eye wash station and safety showers are located and how to use them. Workers who use corrosives and chemicals should know the immediate emergency procedures to take when an exposure takes place. The first aid for accidental skin or eye injuries usually involves flooding the contaminated area with large amounts of water. However, the specific first aid recommendations can vary from one corrosive material to another. For instance, after flushing, hydrofluoric acid exposures may need to be followed with an antidote such as calcium gluconate gel. If there is a large spill of corrosive materials, evacuate the area at once if you are not trained to handle the problem or if it is clearly beyond your control. Alert nearby workers and report the situation so specially trained people equipped with the proper tools and protective equipment can handle the emergency. Obtain first aid if you have been exposed to harmful chemicals. Emergency eye wash stations and safety showers should be present wherever accidental exposure to corrosives might occur. The SDS and container label for a particular corrosive should give specific first aid instructions in case of exposure by skin or eye contact, inhalation, or swallowing. Initial first aid for contact with the skin consists of flushing with large amounts of water. The application should be started as soon as possible after the exposure has occurred. Remove contaminated clothes while showering. The water should be applied with low pressure to avoid further damaging injured tissue. A victim of such an exposure may be in great pain and may require forceful aid while flushing is taking place. Seek professional medical care as soon as possible. For eye exposures, use an eye wash station to flush the eyes for a minimum of 15 minutes. The eyelids must be held open for flushing to be effective. Portable eye wash bottles aren't a replacement for plumbed units as they have only enough fluid to get someone to an eye wash station or shower. Always seek medical attention as soon as possible following eye exposure to a corrosive chemical. For inhalation exposures, medical attention should be sought immediately. The full effects of the exposure may not be evident for several hours. Thus, medical observation and/or assistance during this time is important. For all exposure situations, the affected worker should seek medical attention immediately to ensure long-term damage does not take place. You should now be able to recognize types of corrosive materials and their hazards, identify and read corrosive material labels, recall chemical safety guidelines, know how to safely use corrosive materials, know the proper techniques to store corrosive materials, and decide actions to take in an exposure emergency.